So we're going to use this as an opportunity to determine what are potentially be measured against different reference electrodes. Now notice that we've set up our scale. We have our standard hydrogen electrode right here at 0. We have our silver chloride electrode right here at positive 0.197. And our saturated calomel electrode is going to be right here at positive 0.241 volts. Now, if we were to do a reading on the standard hydrogen electrode scale, and we're to find that it's going to be negative 0.220 volts, I want you to determine the voltage for species A if we were to do it against silver chloride electrode instead, and if we were to do it against the saturated calomel electrode instead. So go ahead and pause the video and try that now. Okay, so what we want to do is we want to just think of this as if we were doing a measurement. We say, all right, species A, is 0.220 below SCE. SHE. SCE is up another 241 from there. So we can say, all right, I need to add those two values together. So I'll have my negative 0.220. I'll add that with my 0.241 to get a distance apart. So we don't care about the sign anymore. So you'll see that that's going to give us, see, 0.461. 461 volts. Now, we want to make sure that we adjust our sign. We're saying that saturated calomel electrode is what I'm trying to do my measurement against. Instead of having it down by 0.220, now we're going to be down by 0.461 volts. So that would be the value that we determine here. Versus the saturated calomel electrode, species A and reaction A, that cell should be giving me a potential of negative 0.461 volts. Now if you had trouble with that one, try it again for the silver chloride electrode. Okay, so when we do silver chloride, same idea goes into play. We say we were this far down, or this far up. We need to add the two distances together. So we'll have 0.220. We'll have another 0.197. So if we add those together, we'll get 0.417. And again, I'm more negative than my reference electrode, so it'll be a negative voltage. So now we'll be down by 0.417 volts. Now, for species B versus the standard hydrogen electrode, we're going to be at positive 0.230 volts. Go ahead and pause the video and determine both measurements against the silver chloride electrode and my SCE. Okay, so if we're at 0.230 against SHE, but we're doing silver chloride, we're going to be all the way up by another 0.197. So what we want to do, sorry, I should have been gesturing to here. Here we are. So what we're going to do now is we're going to say, all right, I measured it at 230. My reference is back at 0.197. And so when I just subtract these two, I should say that my potential versus this electrode is going to be plus 0.033 volts. Now how about the other one? We're now below the saturated calomel electrode. And so we look at the difference between those two. It's 0.011. Hopefully that's something you spot right away. I'm lower than it, so it'll be negative 0.011 volts versus our saturated calomel electrode. So that's how we want to be able to do this. Just set it up as a number line or handle it mathematically once you're comfortable with it. Myself, I still prefer to do this with a number line to keep myself organized and make sure that I'm getting the right result. Because you can see here, positive and negative signs matter a lot when we're talking about our electrodes.